So, Jean-Pierre, I'll let you take it away.
Okay. Thanks for everyone coming. We got a few. We don't have too many folks, so if anyone has questions, feel free to pipe in, and we can try to discuss the things that are of particular interest. Let me start again. This is based off a presentation I made at the SELF conference, the Southeast Linux Fest, that just occurred a little while. I updated it a little bit, but it's basically the same. These are the topics I'm going to try to cover, and I'm trying to be pretty pragmatic here, so this isn't too academic. It's actually down in the weeds on how to set up SSH securely. I'm sure all of us know SSH, but just maybe a little bit of history. This was developed in 1999 as a fork of Tattoo's SSH implementation that he had for several years. His product is closed source now, but it's still very widely used. And his website, ssh.com, is a really great source of information. He's still very active in the community and contributes quite a bit. Some of the core features of OpenSSH, and it's diverged from the original fork quite a bit, but the obvious things are remote access, remote copy. There's two methods there, SCP and SFTP, and then there's a giant ecosystem around it to do a whole lot more. And things that probably most folks know about, you can do just remote execution. You don't have to log in. You can just launch a program on another server. Then it's a Swiss Army knife to get around firewalls. So you can do port forwarding and proxying and all kinds of things to navigate through a complex network, including being able to forward your credentials either with agent forwarding, which is probably a bad idea, and the more recent proxy. There's a typo there. It should be proxy jump command. And we'll cover all of these in a little bit of detail. So probably the first thing to think about when you're setting up an SSH installation, and I would emphasize you need to think about this both on the client and server side. You can expose yourself to a lot of bad guys just using SSH as a client, not only on the server. NIST has a lot of really great recommendations and information about the kinds of vulnerabilities. So if you go to the CVEs, and these are links, I should have mentioned at the beginning that this presentation and a lot of the examples I'm going to show are on a GitHub server. So you can download these and click through these if you need to. So they have a special label for CVEs related to OpenSSH. You can see what's been causing problems. They have a really terrific guide for securing SSH. This is the NIST technical recommendation 7966. Definitely, if you're using SSH in your company or enterprise, you should definitely take a look at this document. And then in general, the SP800, if folks aren't familiar with this, this is NIST recommendation for securing an enterprise. And they have some excellent documentation that's actually fairly readable and a lot around SSH. Most of the vulnerabilities is just controlling access. SSH is really all about access. So as you might expect, it's mainly controlling access. Now there have been vulnerabilities where you can get root access by taking advantage of a buffer overflow, but there haven't been CVEs around that in quite some time. So it's more controlling access. So I'm sure anyone who stood up a server, how long does it take before you start seeing folks probing your brand new server for OpenSSH or ports and trying to log in as root? Last server I stood up, it was literally 2 minutes, and I started seeing attacks on our server. The most common vulnerabilities, this is what the technical document is saying, is poor SSH implementations. Generally, you can read that as old SSH, OpenSSH. It's really important to keep up to date and current with your version of SSH, both on your server and client. Poorly configured access control. This is also very common. There are a lot of knobs to control an SSH, and it's easy to get it wrong. Out of the box, you cannot rely on a secure access control. So no matter what distribution you use, don't assume that you have a secure configuration. Poor management of user keys or passwords, backdoors where you've lost a key and you're not even aware a key is being used to access it. That's really common. If anyone that has to control a large number of servers and is using key-based authentication knows about that problem. Another one is you have a key and you only expected it to be used to, say, run a backup program, but they're using it for shell access. That's also very common. Pivoting is a technique that you can attack one machine and then gain access to the entire network. That's all that means. And then just basic misunderstanding of how to properly configure SSH for security. So I'm going to kind of address each one of those and go through some of these things. So first is the implementation. And I have guidelines as we go. So maybe the most important guideline here is you got to keep your SSH client and server up to date. The latest version is 8.3, so you might want to take a look at your laptop and see what version you're running. The project tends to release twice a year, unless there's a CVE that's important, and then they'll release something right away. Since Heartbleed, they were exposed to the Heartbleed attack. The project has been much more cognizant of the fact that they have to remove weak crypto and poorly designed features. So a lot of the emphasis in the later releases have been removing stuff out of SSH, not adding. So a lot of the crypto algorithms are going away, and you have to upgrade your infrastructure to take advantage of that. They have added some new features. So one cool one I haven't actually tried too much yet is FIDO authentication. FIDO is a hardware security token-based authentication, and I'll talk a little bit about that. And then a more advanced crypto that hopefully is more secure. The next one is improperly configured access control, and this is my second guideline. Don't just assume that what you get out of the box is right. It almost certainly is not. Most distributions will try to make it easy to use, and security is a secondary concern. And that's just a fact of life. Another thing that I see a lot at my clients is they don't want to worry about security. They just want to connect to the remote server, and they'll ask you to remove all the security concerns as much as possible. So there's a lot of pressure, and your DevOps team has to have enough wherewithal to resist that. The server configuration, just to give you an idea of the scope of the configuration options, there are 87 configuration options altogether. They're kind of poorly named, and sometimes you would think one name means something else, but it really doesn't. So I have kind of some general recommendations here is organize your options into functional areas. I also, a lot of people don't realize this, but you can pull in other configuration files with the include option. And that's a good way of decomposing your configuration. The OpenSSH configuration file is a little unusual too, in that the first declaration of an option wins. So if you have the same option mentioned twice in the configuration file, only the first one is respected. The other ones are ignored unless you use a match option. That's a little bit different, and I'll show you that in an example. And what I would recommend is to default to no access and then relax it in the match options. So I'm going to switch over and actually show an example of how I organize. This is my SSHD configuration. Is that readable? Can you guys see that okay?
I can.
Okay. So I'm using a Doxygen annotation scheme. That's what this def group is. So here I just organize, these are all the options related to the daemon process that gets started up, so what port it listens to. And what I do is I show what the default is, and then I override it. In this case, I kept it the same. So here's an example of what I mean. Try to have minimal. So we don't use IPv6. We only use IPv4. So instead of the address family being any, I just set it to INET. That's the daemon. Here's the crypto as an example. So there's 3 different algorithms that you have to worry about: the KEX algorithm, the cipher, the MAC, and the host key. And the host key I do a little bit different. You can see the default is quite a few algorithms being used. In our servers, we only support curve 25519. And we disable everything else. So just that alone eliminates 99% of your attacks, because most of them are not using curve 25519 yet. I selected, I'll have another reference that shows how to select these different algorithms and which ones are the better ones. And then I'll just jump down to the bottom. So you can see there's a hell of a lot of options. So so at the very end, you can have a match option. And what you can match on different criteria on the connection that's being made. So you can say if the client is coming, in this particular case, what I'm doing is say, match on the host name, and if the host name is either localhost or something in the coininc.com domain, my company's domain, I'll enable public key authentication. Earlier in the file, I had disabled all authentication methods, so you literally cannot log into this machine unless you have this kind of host name. So that's an example of how you might want to organize it.
And again, if I understand what you're saying, because you got a match, you don't cover the old config as the previous?
Yeah, it overrides the previous ones.
Because it's match.
Because of match. That's right. Match always wins.
Okay,
all the options not mentioned in match are inherited from the default that you said earlier in the file. So the basic idea is restrict everything as much as possible, and then in the match, loosen it to what you want it to be. And that's a very different model than most distributions. They do the opposite, make it fairly relaxed, and if you want to restrict it for certain users, that's what they'll do.
And if a node matches multiple matches, then which one takes?
It's a first come algorithm again. So generally what you would want to do is organize your matches from most specific first to most generic later. So an example of that is if I have, say, my backup client, and I know it's named sv1.coininc.com, I'll have a match for just that one specific server. And then further on, I'd have the wildcard for the coininc.com domain. And you can match on all kinds of things. You can match on IP address, host name, the time of day, day of week. There's an incredible amount of flexibility there. So here's a simplified example of that. So you can see just what I was saying. Up in the file, at the beginning of the file, I disable, you see they enable the default on Debian is to allow any authentication method. I turn it off, say there are no authentication methods to accept. And then there's another option, public key. By default, it's on. I turn it off by default. And then in the match, I enable the ones I want. It's tricky to get these access controls quite just right. So you should always test the configuration. You can literally lock yourself out of your machines permanently. So it's really important to test the configuration before you go too far. Luckily, there's some built-in facilities. SSHD and SSH, the client, also has this. -T just checks the syntax, and then the -T and -C is a way of checking the access control. So I can show that real quick too. So I'll just test the access first. I was wondering why, so you have to actually say. And it comes back with no errors here. If there had been a syntax error, so let me just make a small change just to show the utility of this. So I put in a non-existent option, and you'll get this kind of diagnostic. And if you had done this without testing and tried to restart the server, it would have failed and the server won't come up. And at that point, you're locked out of your machine. There's nothing to do. So it's really critical to test it. Let me fix that. And the other option is, this one's actually a lot more interesting. So it's -T. It's to test whether you have access. And -C, you give it the configuration of the kind of client that you're going to be connecting from. So I'm going to say I'm going to connect from a host, local host. And then you also give it the I always forget the syntax of this. So and it's a -C. Oh, it's keyword value. So yeah, it's an equal. So if it matches, what it'll do and will allow access, it will spit out the configuration that will be in effect for that connection. If you give it, say you're coming from srv@google.com, it will spit out the option 2. I think it will. Oh, it won't. But it will now show that you don't have all the options to connect will be no. So let me show that again. If I grep for pub key, oh. If I grep for pub key, when I use localhost, you see that public key authentication is enabled. But if I now try to come in from a server at Google, you'll see public key authentication is no. So this is a fantastic way of testing your configuration and specifically the matches to make sure that everything is working correctly. There's a lot you could say also about what are good choices for values for each of the options. There are a couple of tools, not a lot, that can help you with this. Have folks heard of Linus? This is a security scanner, and it has some basic checks for SSH, and some of them are pretty good. So we use that to audit our configuration. OpenSSH it has some more capabilities, but it's a little harder to set up. The main advantage to this is it's directly tied to the NIST standards and the CVEs, so that's kind of a nice thing. One that has gotten a little popularity is the SSH audit. And what this will do, let me see if I can find it. What this will do is audit your the crypto on your system. So here's the report it spits out for my server running locally, and pretty much everything is green, which is good. It doesn't know about certificates, which is something I'm going to talk about. That's what the brown one is. But that's because it hasn't been updated. Now contrast that. So let's try GitHub and see how they come out. And you can see they're using a lot of very weak crypto that's going to be removed, that have been removed from newer versions of SSH. This is an example of a company that's trying to make it easy to connect, not securely to connect. So they're definitely emphasizing ease of connectivity. So here's a really bad one. Like they still enable SSH DSS, and it's been removed in the server for quite some time. And I think this might be out of date. I think 8.3 has removed the client-side ability as well. So that's a kind of neat tool. The only caveat to it is it only checks the crypto. It doesn't check your configuration beyond the crypto settings that you have. So and this is a good lead-in. So we'll talk a little bit about crypto. This is the cool thing. Everyone wants to talk about the crypto. Honestly, I think this is one of the less important things. There's a lot of other things that you can do to secure your SSH before you get to crypto, but it's still important. I can talk a little bit about the different algorithms and the weaknesses, but it's beyond my pay grade. I'm not a crypto person. What I rely on is this site, both the NIST and this GitHub site. He has a really fantastic description of each of the major algorithms to use and some recommendations about which is a proper one. And you'll see that OpenSSH is clearly going in the direction he recommends. So the default is becoming what this Strybaka has recommended. So I have just general guidelines here. If you have a server that's not public facing, you're only using it internally for your own projects or your company's projects, there's no reason to have weak crypto or anything except the best crypto algorithm there. I myself would recommend the ED 25519 that is very efficient, looks to be pretty good quality, and is not sponsored by NIST. So there's no fear of backdoors that NSA might have. The second one is you want to make sure, and this is a very common thing, that the default will be a secure crypto algorithm, but then they'll let you degrade to something that's less secure. So you want to make sure you protect against that. And then again, make sure most folks focus on the server. The client is just as important. You're exposing yourself with the client as well. So this is a crypto I recommend and would use if I have my choice. So for the key exchange, 25519, as I was mentioning, the cipher, the ChaCha20 is very good. It's very efficient. For the the Mac, I recommend the SHA-2 with the ETM. You want to make sure you have the ETM, that if you don't use ETM, it exposes you to certain kinds of attacks. And then for the host and user key algorithm, I recommend the 25519 key, but then layer a certificate on top of that. And then I'll talk about certificates in just a minute. And then for the really geeky folks, they have, in the latest release, in the 8.0 family, they actually have a new algorithm that they claim is quantum resistant. A lot of the algorithms that are being used, especially the curve-based ones, the elliptical curve ones, like the 25519, they're considered insecure against a quantum computing attack. And theoretically, they're not considered secure. I haven't heard or seen anyone actually cracking it, but theoretically it's possible. This quantum resistant algorithm is supposedly resistant. I don't know the math well enough to know if that's for real, but if you guys want to start playing around with it, it is available for you. If you're worried about the Chinese trying to crack your crypto, you might want to consider the quantum ones. Okay, so that's a configuration. Next one I'm going to talk about is authentication. And as I was saying, I think this is usually the most prevalent. It's hard to get statistics, but in my own company, we have been compromised. In 25 years, we've been compromised 4 times where servers have been taken over. And we've always traced it to SSH, and it was always an authentication problem. So the one that was most common is people, we had unaudited keys, or people that had put both their public and private keys on servers. So some of the alternative, there's a whole slew of authentication algorithms that you can use. The ones that are kind of most common are the keyboard and password authentication. That's what most people think of. Public key is if you're, if you know a little bit more, you generally will go to public key. It's easier to use, and also arguably more secure. I actually recommend certificate-based public key authentication, which gets layered on top of PubKey. And then there's a brand spanking new FIDO-based public key, which I'll talk about in just a minute. So some of the vulnerabilities that come around is the password. You need to save the password on all the servers, and it's exposed to all the things that all password-based authentication. So your users are reusing passwords. They put a password in a text file stored on a Google Drive. All those methods make it a poor choice for authentication. We generally disable password-based authentication for any of our machines. The public key is better because you're not saving a password, and it's the credentials are split into 2, the private and public. The private stays on your client workstation. It doesn't leave your control, and it's not available on servers to be harvested theoretically. Now, as I mentioned before, we've been attacked where the attacker took advantage of the fact that some of our users were putting their private keys on servers. There's a bunch of problems with public keys, though. SSH public keys have no lifetime or limit on what you can do with them. So once you have a key, and once it's out there, and once it's lost, this is the critical thing, you lose it for whatever reason, it can be a source of attack at any point in time from then on in for any kind of access control. And where this becomes difficult is if you use public key, you have to distribute your public key to all your servers to be able to authenticate. And that's where the issue comes. If you have lots and lots of servers, how do you remember to remove a key from every one of your servers? that's a really hard problem to solve. And obviously you can come up. You should use automation systems like Ansible to try to manage that, and other techniques, but it's still a fundamental limitation of public key authentication. As I've said a number of times, I recommend certificates instead. They've been around for a very long time, but they're not very well known. It's different than your traditional web-based, the X509 certificate. It's a much simpler and lighter weight thing. You don't have a certificate authority. Each company or individual sets or manages their own certificate. In other words, they serve as a certificate authority, and they provide a number of really nice features. First, they help identify the person. You control the lifetime, and you can control what you can do with that certificate. The big wins here now is you no longer need to distribute your credentials, so you don't need to remove them, and you can age them out. And this works for both the user and the host. So this eliminates the man-in-the-middle attack. So I'm sure everyone knows what I mean by that, where you're SSHing to a new machine. You get the prompt, I don't know this machine, from Adam. What do you want to do? So, and everyone says yes, but who are you really connecting to? You don't know. So you're trusting there, and this is a common man-in-the-middle attack. So a little bit more about certificates. You need to create a key that serves as a certificate authority that signs all the certificates. You then distribute the public part of the CA key to all your servers in the file. I call it CA_keys. And then you distribute the CA key to all clients. You can put it in your own .ssh, but I tend to put it in the workstation's etc/ssh known host file. Then you create a certificate for each user and host. And then you can optionally create a revocation file, which I recommend, but isn't strictly needed because remember, these age out very easily. So here's an example of a certificate. It's always a pub file. So this is the one for myself. Usually the name is ID _ RSA or the type of the key. And you can see the type is an SSH RSA cert version 1. It tells you what the public key is and who the signing CA's key is. And then they give you a few critical pieces of information. Who it is, the serial number, the validity date. Principals is interesting. Oops, sorry, let me go back. Principals is interesting in that you can do a lot of automation in terms of automatic login and other types of things. So the principal is usually your user ID. Critical options are capabilities that you can put in. So for example, what command can they execute? And then what they call extensions. So there are a whole bunch of extensions. I'm enabled only these 4. So I'm allowing X11 forwarding, port forwarding, and user RC. As an example of something I'm disabling, I disable agent forwarding. So with this certificate, I can't forward my keys. Let me show you a little bit how this works. Okay. So let me go into my SSH directory. So I just have a cert here. Normally I would have the public key and the private key here too, but I'm actually saving those on a YubiKey, a hardware device, which I'm going to show you in just a minute. The cert isn't, YubiKeys don't support certs yet, so I have to save this offline. The really critical thing here is I don't have a known host file. And normally, if I'm going to connect to local host here, it will say this is an unknown server. I don't know this machine. So I'm going to turn verbose on to show you what the negotiation is happening. So it's saying what configuration files it's doing. So here, what it's done is the host sent this certificate. Excuse me, the client sent this certificate. It's an SSH RSA cert with a serial number 213. When it was generated, it tried to do a DNS lookup on that host, but it didn't find it because I don't have this machine in the DNS server anyplace. But it found the certificate. It used this RSA host certificate and it matched that. And then it looked up the CA key in the SSH known host file. And that uniquely identified that machine. So there's no need for a known host file, in other words, for each machine. And let me show you what's in that known host file. There's only one entry. You never have to put anything more than this. And all it is a declaration of who the certificate authority is. So this is a cert authority for this domain, my company's domain, what the key type is, and then the actual key itself. And that's it. That's all that's needed. From then on in, no matter how many users and hosts you have with a certificate, you don't need to update any of your server machines. Everything is set up already. So that's I think a tremendous win from a usability point of view, and still have security in place. So just kind of summarizing, you no longer need a known host for your servers. You can completely eliminate man-in-the-middle attacks with this capability. The certificates can be restricted to do all kinds, and we don't really have time to go over this, but you can put a lot of restrictions on what can be done with that particular, in particular, the time scope. So say you have a client that you want to grant access to your server for a day to download some files, or a vendor that's doing some maintenance on one of your machines, and you just want them to be working on it from 2 o'clock to 3 o'clock. You can give them a certificate to do that. You don't have to modify a single thing on your server, and he'll be able to get into the system. So some guidelines: if you do decide to use certificates, you want to use the critical options to limit the exposure. So you say, I only want this certificate to be able to run this one command, not have shell actions. And then the second one, and this is where there is a cost associated with certificates. You now have to set up some procedures and policies for issuing certificates, renewing them, and revoking them. And that centralizes that work. and that's probably why this hasn't become as popular as it can be for this particular reason. So one more topic I want to talk about is these hardware security devices. SSH can work very easily with the OpenPGP card standard. And what this allows you to do is, and since the Linux world really uses PGP quite a bit for all kinds of things, it's a natural kind of capability. So what you can do is, the basic idea here is you create a set of keys that go onto your device. You always have 3 sets of keys. One is an authentication subkey. That authentication subkey can be used by OpenSSH for authentication purposes. Both the public and the critical part here, private key, is stored on the device. And in particular, the private key cannot be extracted from the device. All the crypto is actually done on these devices. In other words, there's a little, it's not just a storage device, it's actually a little embedded CPU that's executing the RSA or the 25519 algorithm on it. So no one can steal your private key, is another way of saying it. They have to have physical presence to be able to use this. Certificates aren't supported, so there are a few limitations, but it's easily worked around, and the certificates aren't sensitive, so there's no real risk there. And then the big win here is you're significantly reducing the risk of losing your private keys and having it go out in the wild. It's really simple to use. To do this, you have to provision the GPG keys to the hardware token. Then you configure GPG agent to emulate SSH agent. It also has support for PuTTY too. So if you use PuTTY, say on a Windows machine or on Linux, it can support those too. And then it's easy to extract the public key to create the certificate. And to my mind, this is just brain dead simple. So let me show you a little bit what it looks like. Anyone using these keys, these hardware tokens? But I'm going to show you mine. So this is, we use YubiKey for a number of different reasons. There are some open source hardware projects that look really neat, that are easy to use. As I say, we're using a commercial version just for some pragmatic reasons. That's all it is physically. It plugs into a USB port.
Is it USB-C?
They have both. So I have a USB-C adapter, but it's actually, excuse me, a USB-A adapter, but the token itself is a USB-C. They have a lot of different form factors, including one that will plug into an iPhone. This is how you use it. GPG has some commands to examine the card and update it and provision it.
Jump here. You still got your camera on.
Oh yeah, thank you. Okay, there it is. So let me do that again. So GPG has a set of commands to manage the device. Ubico, the manufacturer of this particular device, has a bunch of utilities too, but honestly, I generally just use the GPG tools. So this is the information about this device. You give some details on who this is provisioned for. The critical things are the key attributes. I have created 3 keys, and they're all RSA 3K keys. The PGP card standard, you always create 3 subkeys. One is for authentication, one is for signing, and one is for encryption. And then generally you have the primary key that you keep offline. So if you ever, for whatever reason, and it would be very difficult now at this point, but if for whatever reason you believe one of your subkeys have been compromised, you can revoke it and reissue yourself a new key without losing your primary key. So it's an extra level of safety. Now, the key thing for us in SSH is that SSH will reuse this authentication subkey for itself, because that's all SSH requires. It doesn't use the crypto, any other crypto other than that. And you can see that if you use the SSH command now to list out the keys that it knows about. Oh, and that's because I have to restart it. I have to, let's see, what do I have to do? I have to, okay, let me do this. I have to reinitialize it, so I'll do it by encrypting. And this is the part I was looking for. Because I had removed the key, I had to reinitialize the card. So I was just showing you how that's done. Now with the card unlocked, SSH should be able to.
Hey, JP, can you hear me at all?
There's a lot of background noise.
Oh, jeez. Sorry, I had a question, but I'll try to silence that. Go ahead.
Yeah, we can. Oh yeah, I had. That's right. So
there's also a chat function. So if you want to ask questions, but your mic is having problems, you can chat on the left.
Yeah, I see. I had remotely logged in. That's why I couldn't see the key. So I had to exit out of the remote session. So let me show that again. So there's the SSH add command. You can list out your keys. So I have 2 keys here. I have one that's stored locally on the file system. And then the important one here is it's using the key off the card, and you can tell it's looking for this card, the card number. You can also get that information, so you can pop it into an authorized keys file with the capital L option. So like that. And other than that, it's completely transparent. You would never know that you're actually using a key. It's so simple to use. Yeah, so that's hardware security. They're very inexpensive. They're easy to set up, and I found it's very reliable. It's just dead simple to use. Okay, so that's basically what I was going to try to cover. Here's some references for information that you may want to look at. Let's see if we can expand this. There's the OpenSSH project, obviously, probably everyone knows about. There's a particular publication that I mentioned, the technical report that NIST put together, 7966. This is a great read, especially if you're you work in DevOps at a company. This is really a great document to read, just to give you some basic exposure. If you want to track common vulnerabilities or reported issues around SSH, NIST has a terrific site to search for. And then, as I mentioned, this particular GitHub page is terrific. It's a little dated now, but it's still a great approach for looking at it. And then there's a ton of SSH guidelines floating out on the web, because SSH is used every place. A lot of them are not very impressive. The one that's reasonable is the Mozilla one, but they will not have mentioned a lot of the things I spoke about here. So I just be a little careful if you run across a guideline, take it with a grain of salt, and just use some common sense about what's reasonable or not. Okay, that's it. So, got questions?
I have a quick question. For those of us that don't know, what is NIST?
Oh, that's a National Institute of Standards and Technology, I think is the acronym. So this is a U.S. Government agency that has taken the primary responsibility for cybersecurity for the United States federal government. They do two things. They publish a lot of information on best practices for securing software and DevOps types of issues. Many of them are very good, high quality, and definitely excellent resource. And it's all freely available, unlike some of the other DevOps standards are behind paywalls and not accessible. The other thing they do is they actually publish standards or algorithms. So they actually have recommended elliptical curves to use within, and which are required to be used in any federal government agencies. There's some concerns that they have backdoors in them, because they actually have done that in the past. There's clear evidence that they've compromised, for example, some of the RSA infrastructure. So they're not 100% good actor in all cases, but still there's a ton of really great information. They're also the ones that are responsible for maintaining the common vulnerabilities and exposure list. So like Heartbleed, they have a CVE number around it, and they're the ones that manage it and communicate it out to the community. And almost all Linux distributions track the CVE database and make decisions about what needs to be upgraded based on the NIST CVE database.
Thank you.
Other questions?
Hey, Jean-Pierre, this is Ben. I wanted to comment that at one point I was trying to log SSH activity, and especially whether you were using a public key or not, and I found out that the default logging of a Red Hat server at the time did not allow you to do that, and you had to actually turn on verbose logging to actually get it to show up in the logs.
Yeah, that's a actually great example, Ben. Of you just can't assume that it's configured the proper way. So that's a terrific example. Debian, I can't remember what the default for Debian is. I guess we could take a look at that. Yeah, so by default, Debian sets the log level to debug, and it uses syslog based logging with the auth. And those are actually pretty reasonable. When I'm setting up a new server, I generally use debug too, but then after a while I'll go to info because there's just too many attacks going on. I'll ask a question. Are any folks using these hardware security keys?
I've used them.
Okay. And have you found them useful or easy to use?
Yeah, I like them. It's you don't have to. That's not go. You don't type in your password or anything like that. It just works like you said. The main thing, you can tell it to require you to touch it before it authenticates, which they say would be a little bit more secure if someone had like malware on your machine, they couldn't activate it on your behalf, which I kind of like.
Yep, that's actually that's a great example. The FIDO-based authentication, that is the default, by the way, because this particular device I have, the ubiquitous hardware token, it also supports a FIDO protocol, and specifically FIDO2, and FIDO2 does require you to do a touch.
But you can enable the touch even with what you're doing there. Yes. You have to download like a utility from YubiKey to enable it.
Yep, that's right. That's right. Has anyone used certificates? Or does it? Probably not, but how many people knew about certificates? Okay, so this is common from what I've seen. Very few people know them. Go ahead.
I think I've been.
You have used them? Okay.
I think I've encountered it with some AWS VMs that we've got. The AWS gives you a certificate to SSH in with. That was kind of strange to me, being new to it.
Okay. Maybe one thing that came up too is I recommend always having the latest version of SSH. I know some distributions like Red Hat, they make an attempt to backport security fixes. I'm always a little dubious of that myself. So what I do, and we're using Debian primarily in our company, is we backport. Yeah, we backport the software and compile it for our distribution. So we're on Buster now. The latest version, the version I'm running here, which I can show you, is V. It's 8.3. So we're at the latest, but it's a backport, and we did it ourselves. It's super easy in Debian. I haven't tried doing this in Red Hat, but I would assume it's fairly straightforward. And other distributions like Arch, it should be fairly straightforward to do as well.
Are there any other questions for Jean-Pierre? Hearing none, I will thank you so much, Jean-Pierre, for joining us today and showing us about the SSH and how to secure it properly.
Sorry, I had a question if I have decent audio quality. If anyone can hear my question, can anyone understand me?
No, there's a lot of background.
There's a lot of background.
Maybe type your message.
Sure, I'll try. I'll just go ahead and mute and then I'll type it.
Yeah, I was going to suggest that you put it in the chat room over on the left. You got a little word balloon. If you want to type it in, I can read it off. Why do the crypto algorithms look like emails?
Oh, yeah. That's a great thing. It's a little odd too. That is a more common for the newer algorithms. That's the. Let me try to get to them. Yeah, here. What they're trying to show is where this came from, and what organization is sponsoring them. So a good example of that is the new crypto resistant one. It comes from, sorry.
And you've still got your camera on, by the way.
Oh, okay, yeah. Let me switch then. Let me go to it first. Okay, you can see it. So just as you were asking, it all looks like email. And this is all the new algorithms. This is the syntax they're using. And that's what I've adopted too. So I'm trying to use the most modern crypto and using the full syntax. And the one interesting observation I can say is that it shows the organization that sponsored it. And that's what I was mentioning. The quantum resistant one was actually adopted from an alternate implementation of SSH, a tiny SSH, which honestly I've never used, so I don't know anything about it other than they were the first ones to come up with this quantum resistant algorithm.
So that brings up another question I wanted me think of. So besides OpenSSH, I know there's obviously this tiny SSH, and I know about draw error. Do you have any opinions on any of those others?
I don't, honestly. I kind of use OpenSSH every place. I don't. I know like drop error is used in more minimal distributions where there's some resource constraints. I've also used PuTTY a lot for just a client-side implementation, but I don't have much exposure over the alternative ones. I'd be a little nervous also about all these alternatives because I don't know if they have the resources or track record of doing it correctly, honestly.
All right, we have one more question. Are you okay with an older OpenSSH version if its distribution is supported with security patches, like you mentioned, RHEL, or I think you mentioned RHEL backporting?
Yeah. So the standard thing is both Debian and Red Hat, they will cherry pick security patches and then backport them into the current distribution. I'm a little nervous, as I was mentioning. That's certainly acceptable. All my big corporate IT clients, that's what they do. They don't backport. I prefer backporting myself because you can eliminate a whole set of weaknesses. So, for example, Debian, the stable release is still on the 7 series. I'm not quite sure which point version, but they, for example, do not support the FIDO-based authentication. And that is a really neat method that you may want to adopt right away just because the security profile improves so much. So you are getting the CVEs fixed, but you're leaving in all the bad stuff that's still there, like the weak crypto. You don't have, you can't take advantage of the newer algorithms, things like that. But that's really a policy question, and if you're on Red Hat, as an example, you really don't have a choice. You're probably just going to use what Red Hat because you won't get support from them otherwise.
Well, I just checked my version of SSH, and I'm on 7.6 P1, and that's from 7 December 2017. I think I should be worried. This is an Ubuntu distribution.
Yeah, that's right. That sounds about right. So Debian, it takes Debian a long time, and Ubuntu consequently of upgrading some of their stuff. So that's pretty old, and there have been massive changes in SSH. Probably the most important one is they've deprecated a whole bunch of known weak crypto, and you still have that enabled in your version.
Yeah, that was Ubuntu 18.04.4 long-term support.
Yep, exactly. That's right.
So that's one that a lot of companies would be using, just because it's got 10 years of support, but you're working with 3-year-old SSH.
Yep, exactly. This is a conundrum. Yeah, so I see a question that does the client and server have to be the same version number? And the answer is no, generally. They do negotiate the versions, and the only caveat to that is some features have been removed. So for example, I'm running the latest SSH. If I try to connect to some of my clients that are using SSH DSS as one of the algorithms, I can't connect to them anymore. I actually have to find an older version of the client because it doesn't support that. So this is what I was mentioning at the beginning. The project has taken the same strategy that the OpenSSL strategy is that we can't continue to support crappy algorithms and crappy code. And so they're removing a lot of stuff from it. So if you migrate up, you have to worry, do I have backward compatibility with older versions? Generally, and it's easy to check because in the OpenSSH project change logs, they always warn of a backward breaking change. So it's pretty easy to determine if that's going to happen or not.
Well, my organization underwent a security audit, and those audits are based on the DISA, the military security technical implementation guidelines,
Yep.
or STIGs. and probably a third of the findings, and there was a lot of them, were OpenSSH configuration related.
Wow. Okay. Yeah. Yeah. That all of that is based on, I think I mentioned the tool, this OpenSSH tool. That's what this and the STIGs or OpenSSHs basically is built to support those things. So they generally have, especially Red Hat. Red Hat has really excellent support for the OpenSCAPA standard and tool chain.
And I'm just talking about development servers. I'm not talking about production.
Okay. Good. Good. We'll be thankful for that. Okay, so we'll wrap it up.
Well, again, thank you so much for bringing us this information tonight.
Yep.
Ben, do you have anything lined up for next month?
Oh,
Do you have anything?
yeah, I wanted to just mention that you can get this presentation and examples of the configuration files. I really only showed you the server configuration file, but I have a very detailed client one as well at this GitHub site. So feel free to go grab that, and if you have any questions or comments, you can send me an email. I don't do Twitter or those other things. I'm old-fashioned. I like email.
Yeah, I'm the same way.
And also, thank you for the opportunity. This is great. I really like the chance to have some lugs collaborate like this, and we certainly want to learn a little bit of how you're doing things.
Yeah.
Well,
Okay. Well, yeah, we'll have the video up pretty quickly.
Okay, great. Thanks, guys. Have a good night and
Thank
stay
you.
safe.
Thank you. That was a good one.